So we're going to start with the simple type of mirror, which is the plane mirror or flat. Plane mirror or flat mirror. So let's say, for example, and these are, these would be your standard mirrors that you have. Let's say you're right here and you're looking at yourself, or let's say more specifically you're looking at your shoe in the mirror. Now there's two ways you can see the shoe. Remember, to see anything, light has to bounce off that object, reflect off that object, and then go into your eyes. So one way you can look at your shoe is to look straight down, right? Light coming off your shoe can come straight into your eyes like this, and then you'd see your shoe. Or another way you could see your shoe is light could shine onto the shoe, reflect off the shoe, hit the mirror. This is our mirror here. Hit the mirror. Now how do we know, what do we know about the reflection of light off of a mirror or off anything? It's the same angle, right? So it comes in at one angle, it's going to reflect at that exact same angle like this. So this is the second way we could see it. We could see the reflection of our shoe off the mirror. Now here's the thing, our brains cannot figure this out. Our brains cannot figure out that there's some reflection going on. According to our brains, how should light travel? In a straight line, right? So when we look at things, we assume, okay, that's right in front of me, because that's how light normally travels 99% of the time. However, in here, this case, it's not. So our brain doesn't know that. According to our brain, light is traveling in a straight line, coming from some location back here. So there's my shoe. So when I look at my shoe, I don't see my shoe where it really is. I see my shoe behind the mirror. It looks like it's located somewhere behind the mirror, right? And we could fill in the rest of our body. If we were to look at every other part, we would see ourselves, right? Something like this. Like that. Okay? And there's our reflection. We would call it a reflection, but this is our image. This would be what we call our image. Now this particular type of image is called a virtual image. So virtual image, well, some characteristics of a virtual image. Well, first of all, the basics is that it doesn't really exist. In other words, the only reason why I see something back here is because my brain assumes that things travel in a straight line. If I didn't see like that, I would not see an image back here. So it's kind of, you can think of it like a figment of your imagination, in the sense that what you think you see is not actually there. You just think you see it there. Okay? So it's a virtual image. It doesn't really exist. One of the ways you can think about this is, well, it will not show, image will not show up on a screen. That's kind of like the ultimate test you should ask yourself. Will this image show up on a screen? And a screen could be anything. Simply a piece of paper would be a screen. You use screens in the diffraction lab that you just did last week, where you put a screen and you saw the laser light shine on the screen. So that showed up on the screen. If you were to come stick a piece of paper behind the mirror, would anything show up on it? No. Okay, there's nothing there. There's nothing behind it. If you go behind the mirror, you do not find a little guy back there, right? So there's nothing there. This is not a true, or what we'd call a real image. And we'll talk about later what are examples of real images. Okay, so anyway, that's a flat mirror. One characteristic of flat mirrors that you probably have noticed. Let's take another view of this. Let's say this is a top view. Let's say you're just standing here looking at yourself. So this is your head. Here's your eyes. Here's your arms. Here's your hand. Okay, so this is you looking at yourself in the mirror. Okay, going like this. Okay, holding your arms out like this. So one thing you probably noticed is if you wave at yourself with your right hand, what does the guy in the mirror do? He waves back, but which hand does he wave with? The left hand, right. So you wave with your right hand, the guy in the mirror waves with his left hand. In other words, the image is reversed. There's some kind of reversal going on when you look at yourself. So let's look at the reason why let's say I want to, here's my right hand here. If I want to look at my right hand, I would look at the light reflected off, and then reflected off the mirror into my eyes. But according to my eyes, light travels in a straight line back here, right? And so here would be the hand that I see. And if I do the same thing over here, light comes in, reflects into my eyes. If I were to project back, this would be the hand that I see. And so forth. Okay, I could do the rest of my head, my eyes, and so forth. So the point is, when you shake this hand or wave this right hand over here, the hand that waves over here would be this one over here, which would be his left hand, right? Same thing over here, when you wave your left hand, this one is the right hand. Okay, so this would be like a inverted image or a reversed image here. And maybe if you ever looked at like your shirt with words on it in a mirror, okay, how does it look? Okay, the letters get reversed. Yeah, the letters get reversed. Okay, so that's the flat mirror. Those are pretty straightforward, pretty basic. Let's look at the next type of mirror. Next type of mirror is what we call a concave. And this one we're going to focus on for a few days. So this is what a concave mirror looks like. Okay, so notice your image in this mirror is different. Okay, how do you look in this mirror?
Upside down.
Upside down. Good. So you should notice that the things you're looking at in this type of mirror is now upside down. And how else? What about the size of you? Smaller. Yeah, you should notice that you're smaller. Yeah. Question? Liz? Oh, I thought you had a question. So anyway, this would be a mirror. I wonder what it looks like under here. Nothing big. You just see the reflection, don't you? Okay. Anyway, this won't show up on there. So that's a concave mirror. So let's draw this out. So what I'm going to do is I'm going to go over the theory of the concave mirror. And if you do have other colors, I guess not necessarily right now, but later will be useful time to have them. So here's the theory of the concave mirror. Let's say I send in a parallel beam of light. And by parallel, I just mean, well, you know, kind of parallel to the ground, parallel to the surface. It could be a laser. It could be simply a laser that you're shooting in parallel. It could be light from really far away. So the sun, for example, by the time light gets here from the sun, it's basically all of it is parallel. So anyway, it's going to reflect off of this. Notice the normal is tilted like this. So what direction is the reflection going to be? Okay, down. On the other side of the normal, right at the same angle, in fact. What if I sent a beam this way? This one, now notice that the normal is shifted, and so this would go up, like this. Okay, so let me just draw on a few other beams. So I'm going to draw on one like this. This would reflect down also. Let's draw one in down here. This would reflect up. What if I were to draw one straight down the middle, so that it hits right on the normal? How should that one reflect? Just straight back. Yeah, it wouldn't change its direction. Well, it would go backwards. It wouldn't change its angle at all. So one thing I want you to notice, I just drew 5 beams, but I could draw 1 billion beams. And one thing that would happen with those 1 billion beams is no matter what, if they're all parallel to each other, they would all intersect at the same exact point. And this point right here is what we call the focal point, or the focus, because, well, all light focuses at a single point. So that's what we call the focal point. Okay, it's right there when all parallel beams, what they intersect at. If I measure the distance, say from here to here, that's called the focal distance or focal length. Okay, it would be the distance from here to here. Another characteristic of the concave mirror is if I draw a circle, this is just like a part of a circle, right, the mirror. If I draw a circle, it's not a very good circle, but if I draw a circle here, there would be a center of that circle. This is what we would call the center of curvature. We dealt with this when we did like cars going around turns and things like that. It's the same concept. So if you continue the circle, this would be the center. And the distance from here to here would be simply the radius of that circle, right? The radius of curvature would be from here to here. Well, as it turns out, there's a very nice relationship between the center of curvature and the focal point. Anyone see what it might be? The focal point's equal to the center of curvature? No. It is halfway. The focal point is exactly halfway of the center of curvature. So we could write F equals 1/2 of C. And this is a really nice relationship that we'll utilize later. Okay, so that's kind of the basics of these. Now we're going to get into why you look upside down. So why is it you look upside down when you look into this mirror? So I'm going to